once again, statisticians, they like to make predictions. They like to get relationships between data points and predict out. And all we have done up till now is dealing with just one variable. We had the number of people that like oatmeal raisin cookies. How many people? You do an average of those types of things. Calculate the average of a set of all males aged 16 to 18 in the state of Ohio. You have just one variable that is there. But sometimes there's a variable that, two variables that are related together, and you want to be able to create a relationship between these two variables that are related together. So the first thing we deal with is what is called a scatter plot. We have two sets of data. We have two values here. We have two data points that we are trying to create a relationship. Okay, so you have a graph of ordered pairs. You have something called a scatter plot. This is something that you may have done back in junior high mathematics when dealing with some basic statistics. You may have done a scatter plot. Basically, what you're dealing with here is you're talking about two data points. Okay, two sets of information. You have an X variable and you have a Y variable that are related together. And what you do with a scatter plot is basically just plot all the points that are along here. You take, if I have this value here, this creates this value. If I have this value, it creates this value. If I have this value, it creates this value. So what you get is you have two different values. You have an X value, you have a Y value. And you create a relationship where I basically, first off, a scatter plot that relates these data points together. And if we take a look at the scatter plot, well, even though we don't have a single line there, what you would be able to do is come up with a single relationship that allows you to create one line, and with that line we can make predictions. If I had this value of X, I could go to my line and come up with this value for Y. So that's what you're looking for, is if I had this value of X, what's this value of Y? Or suppose these are just smaller values here. I want to come out to this value of X. Suppose I had this value of X, what would be my value of Y here? So what we have here is we have a linear relationship, or a linear correlation. We have a linear relationship because our data points pretty much go into a line. It may not be an exact line. May not be exact, but I can draw one line in there that's going to be a line that represents the data point. Just like when you calculate your average of all your test scores. You get one data point, one value, that's your average value, that represents all your data values or your test values. So you create this one relationship for that one value. Well, our one value here when we have two variables is a line. And this is going to be a positive linear relationship because the slope is positive. It's going upwards to our right. So we have a positive linear relationship, or sometimes they're called a correlation. We have a set of data points. We can still draw a line that's in here, but now this line goes downwards. This would be my relationship that I have. This would be a negative. A negative linear relationship, because I could draw a line in there. And this one line would represent the average of all these data values, if you want to think of it that way. The average of it gives us one thing that represents a whole set of data points. We can have quadratics. where if I take a look at this graph, this looks like a parabola. When you have a parabola, you have a quadratic relationship. Which is in the form y equals ax squared plus bx plus c. So you can come up with a quadratic correlation or relationship. And once again, the nice thing about your calculator does a lot of the stuff for you. Okay, which is nice. It does a lot of you can put your data values in there and you come up with relationships. Now, if we take a look at the last one, we don't have really too much of a shape there. So really you have there's really no relationship. You may say, well, that's a circular relationship. Well, yeah, but what's the radius of that circle? The radius of the circle starts out small with these values and it gets bigger and then bigger and bigger. So you don't have a specific radius that we can come up with there. So you can pretty much say that's going to be no relationship. Okay, once again, these are sometimes called correlation. Correlation is your relationship. Line of best fit. It is an equation that could be an equation that best represents your data values. What's an equation that represents your data values? Relationship between two variables. It's a line of best fit. We will only deal with linears in this class, but if you get into upper level statistics and mathematics, you'll get into values that are more than just a linear relationship. We can have a correlation coefficient. This is an R value. It's a value that's calculated from your sample data values, your ordered pairs. You're going to have a set of ordered pairs. And a value is computed from the sample data ordered pairs that measures the strength of and direction of a linear relationship between two variables. This correlation coefficient is typically between -1 and 1, or it is between -1 and 1. Your calculator pretty much will do that for you. Also, if we had time, we would go through how it's actually calculated, but we don't have enough time to be able to get to that. So it's an R value. It's a correlation coefficient. R is also, when you square that, takes you into a confidence interval. Or square root of a confidence interval will get you an R value. There's a relationship between confidence intervals and R values. The closer you get to 1 or -1, the closer you get to a +1, the stronger your relationship is in a positive. So you'd have a positive slope. As closer you get to a -1, represents a negative linear relationship. As your R values get closer to 1 and -1, that's what you want. And once again, some of your calculators will give them to you, some of them will not. So if we take a look at a scatter plot, number of fires and acres of fires that are burned. Most of the time your values are going to be positive values. So rather than dealing with an entire full-blown XY axis, typically what you will see is just your quadrant number 1. You will just see quadrant number 1 because most of your values are positive. And what you need to do is you need to gauge your X and Y axis so it covers your values that you have here. If I take a look at my X values, my smallest value is 45, my biggest value is 84. So I need to cover up to at least 90. So that's where I would go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. Count up by tens. If you want to count up by 20s, that is fine. If I look at my Y values, my smallest value is 15, and I had to cover up to 60, or 62, so I'm going to go up to 70s by 10. 10, 20, 30, 40, 50, 60, 70. Bless you. And from this point, we're just plotting as close as possible your data points. When X is 72, Y is 62. So when X is 72, Y is 62. So I plot a point up here. When X is 69, Y is 41. When X is 59, Y is 47, or 58, Y is 47. I had that turned around. When X is 58, Y is 19. 58, Y is 19. When X is 47, Y is 26. Once again, all you're doing is you're plotting ordered pairs. You're getting as close as possible. 84, we have 51. 62, we have 15. 57, we have 30. And 45, we have 15. This class here? Oh, no, first period. Nobody turned anything into me, so. Okay. All right. Thank you. And once again, this is just a scatter plot. Just a scatter plot. And if you take a look, we have sort of a linear relationship. It goes upwards to the right. And the more fires you have, the more acres are going to get burned, and that's what you would guess. Nice thing about your calculator, once again, your calculator will do these things. Now, what you want to do is if you have anything in your y equals, you want to either turn them off or clear it. The other thing that you're going to want to do is you're going to go to your stats again. So if I go to my stats and go to my edit, if you have data values in one of your lists, you're going to want to cancel those data values out. So once again, how we do that is a second and the plus sign, and option number 4, clear all lists. Okay, go to your second and your plus sign, option 4 is clear all lists. So you want to clear your lists then. So let's go back to our stats and let's go to our edit. What you should have is you should have data, our list 1 and list 2 that are empty. In list 1, we want to pull in all of our X values. In list 2, we want to put in all of our Y values. So in X1, put in your 72, 69, 269, 58, 47, 84, 62. Okay, so that's your X values. And your list 2, you're going to want to put in your Y values. So hit your right arrow. So what you're getting is a list of ordered pairs here. Okay, now what you want to do is you're going to want to get a scatter plot of these. To get that, you need to make sure that your window covers all your data points. Bless you. So go to your window, hit your window button. Now we could do the exact same thing as we did with our graph. We want from 0 to 90 with our X values. So we can type in 0 to 90 and we space that out every 10. Then our Y values, we want from 0 to 70 and we space that out every 10. So we have a Y min at 0, Y max of 70, and we space that out every 10. Okay, so that will cover your windows. Now, to get a scatter plot down, if we go above your Y equals, you have what is called a stat plot. So it's in our second function and your Y equals, and you get a stat plot. What we want to do with our plot 1 is turn it on. Right now your plot 1 is off. So hit enter. And what you get is plot 1, and you can blink. You got blinker on, and you can hit your enter, and it takes your off to on. It will tell you, ask you, see our X list is our list 1, our Y list is our list 2. That's what you want. And what type of mark do you want there? Okay, I have a plus sign in there. So if we go to now our graph, what you get is you get a stat plot. You get a scatter plot. Is anybody having issues getting that? Yeah. And now you can just go to your stat plot, second stat plot. Okay, it's off, so you want to turn this one on, so go ahead and hit enter. Hit enter. Okay, hit enter, that will turn it on. Okay, now go to your graph. Then you can just go to your stat plot, the second stat plot, make sure that's turned on. On, yep. Now just go to graph. Negative, exactly what we just did right here. We went 0 to 90 with our x. You went 0, no, it goes 0, x minimum is 0. Scale 10, then 0 to 90 with the second one. Minimum, y minimum 0, y maximum is 90. And a scale of 10. There you go. Go to second and stat plot. Y equals. Okay, hit enter. You want to turn it on, so hit enter again. Now just go to your graph. Now the other way of turning on a stat plot, is if you go to your y equals, you can see up above you have plot 1, plot 2, plot 3. When it's highlighted, that means it's on. If I would go up use my right arrow, maybe, I take it up there and hit enter and bring it back down, you can see my stat plot just got turned off. I don't have anything on my graph anymore. And you can see it's not highlighted anymore. But if I go back up and hit enter, that will highlight my plot 1. You'll see my scatter plot just reappears. So that's another way you have of turning on and off your stat plot. Once again, calculator is a very nice tool. If we go to our second set of notes, we'll get started on this. And our second set of notes is our goal is to create a relationship between the two variables y and x. We want to get a relationship. Why? Because we want to be able to predict out. Well, to predict out, we have to go back to our algebraic skills. Because what we want to determine is we want to determine a linear equation for a set of data. Well, what we learned back in algebra was the linear idea of y equals mx plus b. That gave us a linear equation. Well, for us to be able to develop this equation, we also had what was called a point slope equation in algebra. And this was what you worked on. You were given 2 points, or you're given a slope and a point, and you were asked to determine what is the equation of line that includes this point with this slope. And that equation was mx minus x1 is equal to y minus y1, where this will give us an equation that contains a point x1, y1 and a slope of m. And once again, this goes back to what you dealt with in Algebra 1 and also in Algebra 2. So if we take a look at determining an equation of a line with a slope of 3 and containing the point x or 1, 2. This is your x1, this is your y1. This is our slope of a value of 3. And once again, this is all relationships that you dealt with back in algebra. So to determine an equation line, I can substitute in for our point and our slope. So we have 3x minus 1 is equal to y minus 2. All we're doing is we're taking our point, x1, y1, and our slope of a value 3 and subbing it in. Now from this point, we now need to simplify the equation. So we have our distributive property, which is 3x minus 3 is equal to y minus 2. And then we can add 2 to both sides. So we have y is equal to 3x minus 1. That's the equation of a line that contains the ordered pair 1, 2 with a slope of 3. And the hope is, as we go through a couple of these problems, you start remembering what you did back in algebra. We want to determine the equation of a line that has a slope of 0.24 and goes through the ordered pair 4781. So we have a slope of 0.24. We have an x1, y1 of 47 and 81. Go ahead and substitute in. Substitute in for your slope. Distribute your slope through to both the terms. And then determine the equation y equals. Your phone here. So we should have 0.24x minus 47 or 11.28. Add your 81 to both sides. So we get an equation y is equal to what, Janae?
0.24x plus 92.28.
Plus
92.
we got a negative and a positive 81. Jane, what do you get? 69.72. There we go. That's a little bit better. Well, what we want to do is we want to be able to come up with these data points. Given sets of data, given an x variable and a y variable, what would be an equation for us? Well, this is what is called a least squares equation of a line for a given set of data. Least squares. We talk about least squares equation, that's what we would develop. Well, the point that we will go through is x bar, y bar. Okay, the x1, y1 is x bar and y bar. The slope that we go through is xy bar minus x bar, y bar divided by our variance of x. And this will be our slope. Now, if we take a look at this right here, this we'll be able to get out of our calculator. How we calculate this right here is the sum of x times y divided by the number of ordered pairs. Now, the nice thing about your calculator is your calculator will do a lot of this stuff for you. If we go back to just our previous problem what we had, we go back to this problem we just did. Our data points are already there. What we need is we need these values here. To be able to do our calculations. If we look at what we just entered into our data value, into our calculator. Okay, let's go back to our calculator. Our data value should be already entered in there. Data value should be already entered in there. Let's hit our stat button here. Okay, we've done this. And let's go to calculate. So hit your stat button, hit your right arrow, go to calculate. Option number 2 says 2 variable statistics. Let's go to option 2 and hit enter. 2 variable statistics, hit enter one more time. What pops up for us is our X bar, our sigma X. What we want to do is write these down. So our X bar is 61.75. Our sigma X is 12.18. That we all have to square. But if we continue to scroll down, we hit your down arrow here. What we get is our Y bar. Our Y bar is there, so we have 32.375. Now the sigma, the XY bar, once again, this is the sum of XY times N. Okay, the sum of XY times N. If we go to our calculator, keep scrolling down, we get the sum of X times Y. So we have 17,216. And we have a total of how many points? 1, 2, 3, 4, 5, 6, 7, 8. So we have a total of 8 points. Now it does not give you an XY bar. At least the older calculators don't do that. You'll have to do a little bit of calculation here. So you have to take the 17,216 and divide it by 8. You get 2152. So your equation will contain the ordered pair 61.75, 32.375. That's the ordered pair that I will go through. The slope is the one that's a little bit more different, a little bit more involved. We have XY bar, which we calculated to be 2152, minus 61.75 times 32.375. And this is divided by the 12.18 squared. Good to print off the homework you guys have for the next few minutes. Alright, we'll spend a couple days on this here. Have a good day.
Hey, Mr. Gregory, I won't be in here for this period.